study of silver rhyton fragments from the collection of the Pushkin State Museum of Fine Arts. The silver rhyton from the Novakumak barrow was found by archaeologists in fragments. The state of preservation of the vessel predetermined the difficulties in its restoration, as it was not possible to assemble the rhyton as a whole from the surviving fragments. During the first treatment in the 1970s, the vessel was partly restored. However, more than 20 small fragments of the rhyton's beaker could not be put together because they didn't fit together properly. The new restoration of the silver rhyton posed the difficult and important task of joining together all the fragments of this vessel on an inner polymer mold, reconstructed with the general proportions and location of each particular fragment. This was made possible thanks to a direct analogy. A silver rhyton with a protoma of a rider on a horse from the Erebony treasure. Before this time-consuming work, the elemental composition of the metal in several fragments of the rhyton was analyzed. This was done using micro-X-RA-FM analysis of the metal composition. This technique of the analysis has many advantages. They are non-destructive, no sampling or disturbance of material. Efficient, the analysis can be done from the whole group of points on the material surface. Versatile, different materials, objects of different shape and size can be examined without special pretreatment. Highly sensitive, composition of not only major elements but also of trace elements with low concentrations can be determined. And multi-elemental. The analysis can provide information on most of the elements. X-ray fluorescence analysis is performed using special X-ray spectral equipment with the technology of low-power X-ray tubes and collimation of the beam, which allows focusing X-rays at relatively small areas of the samples. For micro-X-ray fluorescence analysis of the metal composition, the conservator selected several fragments of the rhyton socket, which were not connected to each other. Taking into account the specificity of the material, analyses were conducted on M1 Mistral micro-X-ray fluorescent spectrometer, manufactured by the German company Bruker. This device is specially designed for high-precision laboratory analysis of larger samples, measurement of chemical composition and thickness of galvanic coatings of metals. The X-ray tube with tungsten anode enables this machine to analyze a wide range of different sample types, namely metals, metal alloys, and multilayer systems. To make the process of examining the elemental composition of the rhyton fragments clearer, the conservators at the Pushkin State Museum of Fine Arts were given the opportunity to video record the screen of the software used by the Bruker microspectrometer. You can now watch as this high-precision device focuses on a new point of sampling the elemental composition of a single small fragment of a rhyton beaker. When a small sample point is found by the video microscope, the red crosshairs of the spectrometer are displayed. A beam of X-rays is then directed to the target point, and fluorescence emission from that point is recorded by a special detector built into the spectrometer. Note that this method of the exposure to the sample is completely non-destructive. The next step is for the device to measure the obtained spectra. Already at the stage of processing, it is clear that among all the elements in the spectral diagram, the element argentum, i.e. silver, marked in blue on the diagram, stands out significantly. Much less represented elements are copper and gold. The spectrometer also detected lead as a part of the sample point. As a result, the test revealed that the composition of the metal at this spot of the rhyton fragment is an alloy of 4 elements, with a significant predominance of a silver. Now, the spectrometer's video microscope has switched to another fragment of the rhyton. Once again, it focuses on a certain area of the metal surface and identifies a small sample point to analyze its composition. This falls into the red crosshair of the spectrometer. Then the same processes as described above take place. The equipment determines the elemental composition by directing a beam of X-rays at the sample point. The surface is then scanned and the resulting spectrum is measured. The whole process of determining the elemental composition of a metal at a single point takes 1 minute, which is another advantage of such spectrometers. The software of this machine memorizes the results of all the samples taken from the rhyton fragments. As you can see on the screen, all 3 samples taken from different points of the 2 fragments of the rhyton show particularly identical composition. Only tenths or hundredths of percentages of elements differ. The main composition of all 3 samples is a silver alloy, with more than 98% silver. Gold comes next, but its share in the total composition does not exceed 1.5%. Then there is a small amount of copper, with values ranging from 14 to 19 hundredths of a percent. Lead has the smallest proportion in the samples, with only 5 to 6 hundredths of percent. No trace of the zinc was found in all 3 samples. For greater precision and broader sampling of the analysis results, several small sample locations were selected in each rhyton fragment. The spectrometer is now analyzing the elemental composition at the next sample point in the second fragment of the silver rhyton. Compared to the previous fragment, the second rhyton fragment is smaller in size. The collection of spectra is successfully completed, and the analysis of the elements from the second point of the small sample shows similar results as in previous points, including the elemental composition of the samples from the first rhyton fragment as well. After the micro X-ray analysis of all selected points has been completed, the spectrometer generates a final report of the results. It includes a table with the percentages of elements in the fragments for each sample, a table with the average percentages of elements, microscope images of the sample points, and a diagram of the chemical elements in the samples. The results of the micro X-ray fluorescence analysis of the individual fragments of the rhyton were crucial in restoring the original appearance of the vessel. This research provided the conservator with valuable information, not only on the elemental composition of the metal, but also on the further assembly of the individual fragments of the silver rhyton. If the elemental composition in the samples of the 2 soldered fragments differs, it is likely that they belong to different parts of the rhyton. The micro X-ray fluorescence analysis showed that the silver rhyton from the Novakumak burial mound was made of a silver alloy, ligature. The silver content in all samples exceeds 98%. The alloy composition also contains minor inclusions of gold, 1.5%, copper and lead, hundredths of a percent. Inclusions of these elements as impurities are necessary to improve the mechanical, physical, and chemical properties of the alloy. The material of this vessel is a high-grade silver, 990, which fully corresponds to the metal purity of other Achaemenid silver rhytons as well.